We are sitting in a chemistry class, and this semester is almost over. Finally, we're in chapter 9. We're talking about chemical reactions, the true chemistry. A chemical reaction is a process in which at least one new substance is produced as a result of chemical change. There are actually 5 categories of chemical reactions when you look at what's going on between the reactants. We have combination reaction, decomposition reaction, displacement reaction, or it is also called single replacement reaction, exchange reaction, also called double replacement reaction, and combustion. Combination. A combination reaction is a reaction in which one single product is produced from 2 or more reactants. This is a generic representation of a combination reaction. Substance X reacts with substance Y, and these is combined together to form only one product. An example, burning hydrogen in oxygen to produce only one product, water. That is a combination reaction. Decomposition reaction. Decomposition reaction is kind of the opposite of combination reaction. A combination reaction is that 2 or more reactants, one product. For decomposition reaction is one reactant, 2 or more products. A generic representation of a decomposition reaction, and an example. Water can decompose to produce hydrogen and oxygen. If any of you remembers the reaction example we used on the last slide, that was the opposite of this one. Hydrogen burning in oxygen to produce water. So you may want to ask, which way does the reaction go? Does it go from hydrogen oxygen to water, or does it go from water to hydrogen oxygen? Well, it depends on the reaction condition. It can go either way. If you're burning hydrogen in oxygen, it will produce water. If you apply some suitable condition on water, not burning water, of course, you cannot burn water, then water can be decomposed into hydrogen and oxygen. Displacement reaction, which is also called single replacement reaction, a chemical reaction in which one atom or molecule replaces another atom or group of atoms from another compound. Like this, substance X reacts with a compound in which you have Y and Z combined to form a compound. X reacts with YZ, X will kick Y out, replace the position of Y and combine with Z, Y now is by itself. This is called displacement. X displaced Y in the compound. X takes the position of Y in the compound. An example, zinc reacts with hydrogen chloride to produce zinc chloride and hydrogen. Hydrogen is replaced out by zinc. So zinc now takes the position of the hydrogen combined with chloride ion. Hydrogen is out. Hydrogen is out. Hydrogen doesn't stay as hydrogen atoms. It stays as hydrogen molecule, which is H2. Exchange reaction, also called double replacement reaction, a chemical reaction in which 2 substances exchange parts with another and form 2 different substances. a generic representation. So AX react with BY. They exchanged the partner. A in the product, A combines with Y, B combines with X. So produces AY and BX. An example? Oh, wait a minute. Many times when you look at the reactions in this chapter, you may see AQ in parentheses, S in parentheses, sometimes you see L in parentheses or G in parentheses. Well, L, G, S represents the states of the substance: liquid, gas, solid. AQ means the reaction is happening in an aqueous solution, in a water-based solution. And if you see AQ and S labeling in the same reaction, that tells you this substance that is labeled as a solid is something insoluble in water. So that's why it is not labeled as AQ, it is labeled as S. It is insoluble in water. This is a double replacement or exchange reaction. As you can see, sodium ion before combined with sulfate, lead ions combined with nitrate ions. In the product, sodium combined with nitrate, sodium nitrate, lead combined with sulfate, lead sulfate. Exchange reactions. Combustion reaction, a reaction between a substance and oxygen that proceeds with the evolution of heat and light, usually from a flame. I bet we all have combusted something before. Here is an example. C3H8, that's the molecule for propane. That's propane molecule. I'm not sure how many of us have used those little propane can. That's what it is inside. So propane is burned in oxygen to produce carbon dioxide and water. So what happens in the combustion reaction is that each element in the substance that is combusted, here we have carbon and hydrogen, each element in the substance will combine with oxygen. Carbon combine with oxygen, carbon dioxide. Hydrogen combine with oxygen, water. That's what happens in the combustion reaction. Another example, we just talked about this actually earlier in the combination reaction. When you combust hydrogen in oxygen, you're going to produce water. That's a combustion reaction. To balance it, put a 2 here, put a 2 here, it is balanced. So that is another example of a combustion reaction. Concept check. Classify each of the following reactions as a combination, decomposition, single replacement, double replacement, or combustion. A. Magnesium reacted with HCl. In the product, H is out, staying by itself. The place is replaced by magnesium. Single replacement or displacement reaction. Magnesium displaced hydrogen combined with chlorine or chloride. Single replacement or displacement. B, HCl, H3, ammonium chloride, 2 or more reactants, 1 product, combination. So the second one is combination reaction. Last one, a substance reacted with oxygen. Each element, nitrogen, hydrogen, combine with oxygen, nitrogen combine with oxygen, nitrogen monoxide, hydrogen combined with oxygen, water. All right, combustion reaction. Now we just talked about one way to classify chemical reactions by looking at what happened between the reactants. The reactions can be classified into one of the 5 categories. Now there's a different way to categorize all chemical reactions. In this case, no surprise, we look at what's going on with the electrons in the reaction. Remember, electrons are troublemakers. So when you look at what's going on in the electrons during a chemical reaction, all chemical reactions can be classified into one of the 2 categories. Oxidation reduction reaction, which is called redox reaction, and non-oxidation reduction reaction, non-redox reaction. A redox reaction is a reaction that there is a transfer of electrons between the reactants. If in the reaction, electrons are transferred between the reactants, then it is called a redox reaction. Then no surprise, if a chemical reaction doesn't involve any transfer of electrons, it is a non-redox reaction. But how do we know, by looking at a reaction, how do we know whether an electron or electrons are transferred or not? In other words, how do we know if a reaction is a redox or non-redox reaction? That will be our topics for the next couple episodes.